Lesson 13.4, Law of Sines. Thus far up to this point we've learned that we can find the area of right triangles or the area of any triangle given a height. So this is going to be a big step for us to realize that in the past, where we were given a height of the triangle, we would take 1/2 base times height. But we always needed the height. But for the area of a triangle, we can find the area if we know two sides and the sine of their included angle. So to be clear about that, we would have to have two sides and an angle in between. If we know that, that's called side angle side, and we can find the area of that triangle. Case in point, the area of this triangle, even though we don't have a height, would be 1/2 a side times a side times the sine of 40, the angle in between. Calculate that out. Now notice we are in degrees, so make sure your calculators are in degrees. And that would give us approximately 26.033 for area. With centimeters, that's centimeters squared. Same for this triangle. It's 1/2 12 times 15 times sine of 58. Calculate that out. Should get approximately 76.324. Now, the true law of sines that we will talk about, that this lesson is named after, is that if you have an angle, let's say angle A, and we have its opposite side. Now pay notice to that all of the angles have capital letter A, capital letter C, capital letter B, and the sides opposite those angles are the lowercase letters. And that's necessary for us to understand that, because if we are given information without a picture, that will be helpful for us to draw a picture. And what this tells us is that if you take the sine of the angle A over the side opposite it, that ratio will be the same for any of the other pairs. When I say a pair, I mean an angle's sine, or a sine of the angle, over its opposite side. One nice thing about this is that if you know that you have a side information, or if you're given side information, or angle side angle information, your answer or your possibilities will be one possible triangle form. It may not seem like much at this point, but it is in a couple of screens to come. So let's try this out. Here we have angle, angle, side. So the law of sines would say the sine of the angle given us, now we want to choose a pair. So that means here's an angle and here's its opposite side. So let's start with that. Sine of 53 over its opposite side is equal to, and then we have 100, so say sine of 100 over its opposite side. If we cross multiply, if I'll do this longhand for the first one, I say 9, times sine of 100 equals C times sine of 53 divided by sine of 53 And that is what C will equal. 9 times sine of 100 divided by sine of 53. Be careful with your parentheses, otherwise you will not get the right answer. And this is the answer you should get. C should be equal to 11.098. If you don't get that, check your parentheses or how you're entering this calculation into your calculator, or check if you are in degrees or radians. One nice thing is that if we have two angles given, we know the third angle. That would be 180 minus 100 minus 53. So if we calculate that, then we have our angle. So angle A will be equal to 27 degrees. So we have C, which is now about 11.1. So I'll say equal to 11.1. 9, and we need the third side. Well, it's not a right triangle, so we cannot use Pythagorean, but we can use law of sines again. So let's start again the same way as sine 53 over 9 equals, we know what A is now, the angle A, so sine of 27 over its opposite side. Cross multiply that, and A should be approximately 5.116. And that is solved using the law of sines without it being a right triangle. Pretty powerful stuff. Now here's where it gets a little bit more interesting. How do we find the answers when there's more than one possible triangle, or maybe there's no possible triangle? Well, if we are given side-side angle information, that's when things get interesting. Meaning we're given two sides and an angle outside of, not in between those two sides. That causes some things to happen. Whether, given the information, either there will be no possible triangles to be created, or one possible triangle, or two. And how we decide that comes from B sine of A. Now B sine of A is the length of the third side of a right triangle. And if you know that length, meaning it would be a right triangle if you had that, and that's right here, if you knew that length, then you can compare the information you have to that length. And that will tell you, the comparison of those two will tell you whether or not no triangles are possible, one triangle or two triangles. Now, I'm going to break this down to you step by step. And that means the first thing you're going to want to do is, when the information given to you, you're going to decide from what they give you, is the angle acute or obtuse. And if it is acute, we will look at this relationship, this relationship, this relationship, or this one. And that will tell us what or how many possible triangles there are. If we're given obtuse, then we will check out this relationship and this relationship. We're going to go through some examples, and we will take a look at those step by step, and that will be in part B. So this ends part A.